In this video, we want to learn how we can use double angle identities for simplifying trigonometric expressions. Here we have a list of double angle identities. Sine of 2 theta is 2 sine theta cosine theta. Let us start with this one. Let's see how we can use this identity for simplifying trigonometric expressions. Look at this first example. 2 sine of 15 degrees times cosine 15 degrees. If you pay attention, this expression exactly matches with this. 2 sine theta cosine theta is equal to sine of 2 theta. Here we have 2 sine 15 cosine 15. So the theta here is 15 degrees. Please attention again. 2 sine theta cosine theta is equal to sine of 2 theta. Whatever the angle is here, in the other side we have double of that angle. If here is theta, the other side is 2 theta. So based on this identity, 2 sine of 15 degrees cosine of 15 degrees is equal to sine of double of these angles. Double of 15, 2 times 15 is 30 degrees. And based on the special triangles, we know that the sine of 30 degree, if we draw a triangle here, if we suppose here is 30 degree, we know that for 30 degree here is 1, the hypotenuse is 2, adjacent is radical 3. Sine of 30 degree is opposite over hypotenuse, and so this equals 1/2. So we use this double angle identity for simplifying this expression, and this expression is equal to 1/2. But attention, sometimes we use this identity in the other order. We have this expression and we replace it with the other side. Sine of 2 theta is 2 sine theta cosine theta. Let me show you an example here. Look at this example. Sine of 2 theta over 2 cosine theta. We want to simplify this expression. The reason that for simplifying this expression we think to this identity is that in numerator the trigonometric expression is with 2 theta, but in denominator cosine is with theta, so the angle doesn't match with each other. So we think to changing this angle from 2 theta to theta. For that reason, we use this identity. Based on the double angle identity, based on this identity, sine of 2 theta is 2 sine theta cosine theta. And we leave the denominator 2 cosine theta. Now look at the numerator and denominator. You can see that we can cancel cosine theta with cosine theta, 2 with 2 cancels, and we have only sine theta. So this equals sine theta. Before I show you how we can use other identities here for simplifying trigonometric expressions, let me explain something that is really important. Let's focus on this identity again. Sine of 2 theta is 2 sine theta cosine theta. So based on this identity, if we want to use this identity, what is sine of, for example, 6x? Sine of 6x based on this identity is equal to 2 sine of 3x cosine of 3x. Let me explain to you how I use this identity to write sine of 6x in this form. What exactly this identity tells us? Please attention. Sine of 2 theta is 2 sine of theta. What is theta? Half of this angle. Cosine of theta. What is theta? Half of this angle which is here. So if we want to use this identity for sine of 6x, then this equals to 2 sine of why 3x here? Because when it is 2 theta, the other side is theta. So if here is 6x, the half of 6x is 3x, cosine of 3x. So we can use this identity to write sine of 6x in the form of 2 sine of 3x, cosine of 3x. And depending to the question or expression that we want to simplify, we can use this double angle identity not only for 2 theta, for anything like 6x, 4x, 10x, whatever is here in the other side is half of this angle. Let me show you another example. Suppose you have sine of 10x. You can write this as 2 sine of 5x cosine of 5x. And let me show you the other way that we can use this identity. Here we know that 2 sine of theta cosine of theta is sine of 2 theta. Now I will give you an expression like this, and you should be able to write the other side, the left side. Suppose you have 2 sine of 7x cosine of 7x. This equals to what? This equals sine of 14x. Because whatever is here, in the other side, in the left side, we have double of that. Here is 7x, so in the other side we have 14x. Let me ask you another question. 2 sine of x over 2 cosine of x over 2. This equals to what? This equals sine of double of these angles. Here is theta, the other side is 2 theta. So if here is x over 2, this side would be double of x over 2. What is 2 times x over 2? What is double of x over 2? 2 times x over 2 is x. So based on this identity, if we want to simplify this expression, we can write it as sine of x. Because whatever the angle is here, in the other side should be double of this. Double of x over 2 is x. This is the way that you have to learn identities. If you just memorize an identity like this, and you think that you can use it that way, it never works. You have to understand the relation between the left side, the right side, and of course, not always in the left side you would see 2 theta. Maybe instead of 2 theta you have 4 theta, 6 theta, 10 theta, whatever. You have to understand that whatever is here, in the other side is half of that. Or if you have the right side, then in the left side it's doubled. For all the identities that you learn, you have to understand them like I explained here fully. Then you can use them for simplifying expressions, for proving other identities, and basically you can use it for whenever you need it. Okay, let's continue. Now here we have an example that we can use this identity for that. But before we do this example, let's see what we have here. For cosine of 2 theta, we have basically 3 formulas. Cosine of 2 theta is cosine to the 2 minus sine to the 2. Sometimes for cosine of 2 theta, instead of this, it's better to use the other formula, 1 minus 2 sine to the 2. And sometimes we can use this formula, 2 cosine to the 2 minus 1. Maybe you wonder why we have 3 formulas. Because basically these are not 3 formulas. These are one formula that is basically this formula. The main formula for cosine of 2 theta is this. But with the aim of Pythagorean identity, we can write this expression in these 2 forms. So basically they seem different. These 3 formula seem to be different, but actually they are the same. But the main question that you have to ask yourself, when we have to use each of these, when I have to use the first one, when I have to use the second one, when I have to use the third one, the answer is depending to the expression that you want to simplify, depending to the question that you want to prove. Let me show you an example. For example, look at this. We have 1 plus cosine of 2x or 2 theta. For this one, for example, attention, we have a cosine of 2x plus 1. We have a 1 here. This 1, attention, this is positive 1. With this negative 1 can be cancelled. So for this expression, it's a good idea to use this case, this one. Because 2 cosine to the 2 minus 1, this minus 1 with this plus 1 cancels. This is the way that you have to figure out which one of these is proper to use for that question. So it depends to the question that you are working with. You can figure out which formula to use. You have to choose the one that simplifies better in that expression. Okay, let's do this question. Focus on this one. Cosine to the 2 minus sine to the 2. Before I show you this, attention, if here was plus, then the answer is 1. Because of the Pythagorean identity, sine to the 2 plus cosine to the 2 is always 1. But this is not plus, this is minus. And whenever we have cosine to the 2 minus sine to the 2, we remember this. Cosine to the 2 minus sine to the 2 is cosine of 2 theta, cosine of double of the angle. So, based on the identity that we have for cosine, this equals to cosine of double of these angles. What is double of pi over 8? What is 2 times pi over 8? 2 times pi over 8 is pi over 4, because 2 with 8 simplifies and we have pi over 4. So cosine to the 2 of pi over 8 minus sine to the 2 of pi over 8 is cosine of pi over 4. Again, attention, these angles is doubled to the in the here. Cosine to the 2 theta minus sine to the 2 theta is cosine of 2 theta, double of the angle. Now if you remember from special triangles, cosine of pi over 4 and also sine of pi over 4 is equal to 1 over radical 2. 1 over radical 2 is sine of pi over 4 and cosine of pi over 4, which if you like to rationalize it, you can write it as radical 2 over 2. But it's completely fine to leave it in this form. Now look at the next example. 1 minus 2 sine to the 2 pi over 12. This should remind you this formula. 1 minus 2 sine to the 2 is cosine of double of the angle. So this equals cosine of double of this angle. What is double of pi over 12? Double of pi over 12 is 2 pi over 12, which is pi over 6. So this equals cosine of pi over 6. But what is cosine of pi over 6? Cosine of pi over 6 or 30 degree, pi over 6 is 30 degrees. Cosine of pi over 6 is radical 3 over 2. Based on the special triangles, if you remember, if we suppose here as 30 degree, opposite is 1, adjacent is radical 3, and here is 2. Cosine of 30 or pi over 6 is adjacent over hypotenuse, radical 3 over 2. Now look at the next example. 1 plus cosine of 2x over cosine x. The reason that for simplifying this expression we have to think to double angle identities is that in numerator we have a trigonometric function with 2x, but in the denominator it's x, so they don't match to each other. We have to change one of them to the other one. So now we think to using the identity for cosine of 2 theta. But which one of these we have to use? Of course, the one that if we use, it helps us to simplify. Please pay attention. Here, for this case, this one is the best one to use. Why? What is the reason? Because if we substitute this for cosine of 2x, this minus 1 with this 1 here, they cancel each other. But if you, for example, use this one, we have 1 here and another 1, 1 plus 1 would be 2. So it's not helpful. So the one that here works better than the others is the last one. So we use this one for cosine of 2x. Let me show you how it works. So this equals 1 plus 2 cosine to the 2x minus 1. So we substitute cosine of 2x with 2 cosine to the 2x minus 1. Now, all of this over cosine x. 1 with minus 1 cancels. What we have after? Then we have in numerator 2 cosine to the 2x all over cosine x. Cosine to the 2x is cosine x times cosine x. So 1 cosine from numerator with 1 cosine from denominator cancels, and the final answer for this is 2 cosine x. Because 1 cosine from numerator with 1 cosine from denominator cancels, 1 cosine remains in the numerator and a 2, so the answer is 2 cosine x. Look at the next example. 2 tangent of an angle like theta all over 1 minus tangent to the 2 of same angle. So this should remind you, of course, this formula. 2 tangent theta all over 1 minus tangent to the 2 of same angle theta. Based on this identity, this equals tangent of double of the angle. Whatever is here, you have to double it and put it here. If here is theta, here is 2 theta. So, as we can see, here the given angle is 22.5. What is double of 22.5? 2 times 22.5 is 45 degrees. So this equals tangent of 45. And tangent of 45 is 1. Because if you remember the special triangle for 45, 90 degree, 45, 45 here also, 1 root 2. The tangent of 45 is opposite over adjacent. 1 over 1 is 1. So the value of this expression is 1. We simplify this expression. If you use a calculator and calculate this with a calculator, you would see that it equals 1. Now look at these examples that are a little maybe harder. Cosine to the 2x all over cosine of 2x plus sine to the 2x. The thing that here we notice immediately is that these two have x as the angle, but here is 2x. This trigonometric expression here doesn't match with the others. So we have to change this and make it similar to the others. So we want to make this angle x. It is 2x and we want to make it x. So we use double angle identities. But for cosine of 2x, we have 3 different formulas. Which one works here better? Let's see. For cosine of 2 theta, we have 3 formulas. Which one is better for this question? Please attention, in this first one, cosine of 2 theta is cosine to the 2 minus sine to the 2. Keep this in your head. cosine to the 2 minus sine to the 2. Here, if you attention, if you use the first formula, which was cosine to the 2 minus sine to the 2, this minus sine to the 2 with this plus sine to the 2, they cancel each other. So definitely the first one is the best one to be used here, not the other ones. Because if we replace cosine 2x with that, it helps us to simplify the denominator. So we use the first formula. So we have cosine to the 2 all over cosine to the 2x minus sine to the 2x plus sine to the 2x. So we substitute this with the identity, which is this. Now look at the denominator. Minus sine to the 2 plus sine to the 2 is 0. And we have cosine to the 2 in numerator all over cosine to the 2 in the denominator, and this equals 1. Now look at this. And look at here. 2 sine theta cosine theta is sine of 2 theta. 2 sine theta cosine theta is sine of 2 theta. Whatever the angle is here, in the other side should be doubled. So based on that, you should be able to find and simplify this expression right away. So this equals 2 sine of something, cosine of same thing. It equals sine of double of these. So this equals sine of, what is double of theta over 2? Double of theta over 2 is theta. So this equals sine of theta. And that's it. 2 sine of theta over 2 cosine of theta over 2 is sine of theta. Look at the next example. 1 minus cosine of 2x all over sine of 2x. If you pay attention, here the angles are the same. So we have no reason really to use double angle identities here. But the problem is that if we don't want to use double angle identities, we have no formula from basic trigonometric identities to simplify this. If in numerator we have 1 minus cosine to the 2 of an angle, then we could say, based on the Pythagorean identity, this is sine to the 2, based on the basic trigonometric identities. But we have only 1 minus cosine, not cosine to the 2. So we don't have a direct formula from basic trigonometric identities to simplify this. So we can think to using double angle identities, double angle formulas. For sine of 2x, for the denominator, if we use the double angle identity, it's 2 sine of x cosine x. Sine of 2x is this. But what we have to use for cosine of 2x? Because for cosine 2x always we have this problem. Which one to use? We have 3 formulas. Which one to use? Attention, we have 1 minus cosine 2x. Because we have 1 minus cosine 2x, please pay attention. We have 1 minus cosine 2x. Which one of these 3 formulas is better to be used for cosine of 2x? Of course not this one, because we want to get rid of this one. So we have to use one of these 2 formulas that have 1. But attention, we have a minus here. So if we use this one, then we have 1 minus this expression, 1 minus 2 sine to the 2x, and then 1 minus 1, it cancels. So which one is the best one to be used here? The second one. So for this example, we use 1 minus 2 sine to the 2, 1 minus 2 sine to the 2 for cosine of 2 theta. So memorize this formula, 1 minus 2 sine to the 2. So here, for simplifying this expression, in numerator we write 1 minus 2 sine to the 2x. Here is 2x, so here is x. Now if we simplify numerator, in numerator we have 1 minus 1, which is 0. 1 minus 1 is 0. Minus times minus would be plus, so we have 2 sine to the 2x all over 2 sine x cosine x. 2 from numerator with 2 from denominator cancels. 1 sine from numerator with 1 sine from denominator cancels. Attention, sine to the 2 is sine x times sine x. 1 sine with sine cancel. So in numerator we have over sine x and over cosine x. So this equals sine x over cosine x. But we know that sine over cosine, based on quotient identities, sine over cosine is tangent x. So this expression is equal to tangent x. Now look at the last example, which is a little harder example. Sine x times cosine of 2x. The first thing that maybe you should think about is that to replace this with one of the identities that we have called cosine of 2x, because this is sine of x, this is cosine x. So the angle of this trigonometric expression doesn't match with this. But for example, if we substitute cosine of 2x with cosine to the 2x minus sine to the 2x, it really doesn't help to simplify the expression. Even it makes the expression more complicated, because then we have sine x times cosine x times by this, and nothing simplifies. So it seems that substituting this with one of the formulas that we have for cosine, one of these formulas, doesn't help. So what we have to do then, if it doesn't help, what we have to do here, we have sine x times cosine of 2x. So again, please pay attention, we have sine x times cosine x. Let me again tell you something about this identity that we have for sine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. Please attention to this part. Sine theta cosine theta. Whenever we have these two multiplied by each other and the 2 here, all of this is equal to sine of 2 theta. So based on this identity, sine of 2x is 2 sine of x cosine of x. So if I ask you, suppose this is not here, if I ask you what is this 2 sine x cosine x, you have to tell immediately sine of 2x. But what if this 2 is not here? If the 2 is not here, how we can get rid of the 2 here? Suppose we want to eliminate these 2 from here. To get rid of these 2, we have to divide this side by a 2, and we have to divide the left side by 2. By dividing both sides by 2, we can get rid of these 2 here. Let's divide both sides of this by 2. By dividing both sides of this relation by 2, we have, in the right side we have sine x cosine x. So we divided this by 2, this 2 is gone. But if we divide the left side by 2, in the left side we have sine of 2x over 2, which can be written as 1/2 sine of 2x. So from now on, whenever we see a sign with an angle multiplied by a cosine with the same angle, we can combine these two and write it as 1/2 sine of double of that angle. Sine of x times cosine of x is 1/2 sine of 2x. So let's see what we had here. We wanted to simplify this expression. We noticed to this, and then based on what I explained to you, we can write this as 1/2 sine of 2x, because sine of x times cosine of x is 1/2 sine of 2x, and we leave cosine of 2x here. Again, please pay attention. What do you see here again? A sine with a cosine multiplied by each other. Forget this for a moment. Suppose this 2 is not here. Focus only on these two terms. Sine of 2x, cosine of 2x. Sine of 2x times cosine of 2x is again 1/2 sine of double of the angle. Let me explain this here again. Whenever we have sine of theta, cosine of theta, this equals 1/2 sine of 2 theta. Whatever the angle is here, in the left side is doubled. So, sine of 2x times by cosine of 2x is 1/2 sine of 4x. Let me show you, before I continue this question, more examples about this. Suppose I am asking you, what is sine of 15 degrees times cosine of 15 degrees? You have to say this equals 1/2 sine of double of these angles. Double of 15, 30. And sine of 30 degrees, 1/2. 1/2 times 1/2 is 1/4. So this expression is equal to 1/4. Let me ask you another question. Suppose I am asking you, what is sine of 20 degrees times cosine of 20 degrees? Sine of 20 times cosine of 20 is 1/2 sine of 40. Now let's back to this question that we had here. Instead of this expression, we wrote 1/2 sine of 2x. So let me rewrite again the 1/2 here. Then when we look at this, again by using the identity, sine of 2x times cosine of 2x is 1/2 sine of 4x. So finally this equals 1/2 times 1/2 is 1/4 sine of 4x. I know this question was a little tricky, but I hope you understand what happened. First, we substitute this with 1/2 sine of 2x. Then this sine of 2x times by cosine of 2x is again 1/2 of sine of 4x, which multiplies by this 1/2, and the final answer is 1/4 of sine of 4x. I hope by watching this video, now you are more familiar with double angle identities and how you can use them for simplifying trigonometric expressions. If you like to learn more about these identities, watch my video about proving identities using double angle identities. If you like this video, please subscribe in my channel, and see you in the next videos.